Welcome to the 19th day of the 21-day data challenge by Lighthouse Labs. Fair warning, this video contains a solution to today's challenge, so please attempt the problem before continuing on. Reference this video if you get stuck or want to see an alternative way to tackle the problem. And with that said, on to the day 19 challenge. Let's go ahead and load today's challenge. You see that the difficulty is set to easy and it's worth 5 points. Reviewing today's question, it looks like we're analyzing board games again. We'll be answering these questions by using a histogram. In the tutorial, we see code that might help us in our analysis, so let's go ahead and copy this. Scrolling down, we see that the first question we need to answer is, what type of distribution does the column average time have? Scroll down here, paste that tutorial code, and instead of analyzing numerical data, we'll analyze the average time. Let's go ahead and run this and see what we get. Well, we do have a histogram. It's kind of difficult to understand what's going on here. It seems like we'll have to play around with the options to make it a little bit more useful. Loading up the documentation, we see that the first value, x, are the input values, or the values that we want to analyze. The second value that we have there are the bins, and the bins define a number of equal width bins in that range. Depending on the data, we'll have to play around with this. The next option we have is the range. It defines the lower and upper range of the bins. If it's not provided, the range is set to the x minimum and the x maximum. Let's go back and take a look at the histogram. So it seems like the majority of our data is centered between 0 and 500, so the range function might be quite useful to us. Let's go ahead and take a look at the x minimum and the x maximum of our data. We'll take the data frame and take a look at the column average time and call the min function. We see that the minimum is 0, as in 0 seconds. Copy this and we'll paste it again, and then instead of calling the minimum, we'll call the maximum. We can see that the minimum playtime is 0, whereas the maximum is 22,500. Visually looking at this chart right now, we see that the majority of the distribution is set between 0 and 5,000. It might be worthwhile to set our range. So taking a look at the documentation, we see that to set the range, it takes a tuple, but we haven't worked with tuples before. Googling tuple in Python, we can see that tuples are used to store multiple items in a single variable, and this is an example syntax of how you would use it. So let's go ahead and use something similar to define our range. Type in comma, set the range equal to 0 as our starting number and 5,000 as our maximum number. And we're doing this based on the visualization right here. Let's go ahead and run this. And with this updated chart, we can see that we could further narrow this down because the majority of our data exists between 0 and 1,000. So let's go ahead and do that. We could further narrow this down, but it seems like we have a decent enough visualization to be able to determine our answer. The final thing I want to tackle is the bins, just to check whether or not 40 is a correct distribution. To do this, I'm going to use the function count to determine how many results we have. It seems like we have 5,000 results, so doing basic math, taking 5,000 and dividing by 40 bins yields us with 124 results per bin, which is reasonable, and it provides us with a result that we can use. Taking a look at this histogram, we can make the assumption that it is right skewed. Scrolling down to the answers, we see that there are 3 different options that might be correct. Let's go ahead and solve question number 2. Do games that have a great average rating have longer play times? And to answer this question, we're going to filter out games that have an average rating of 9 or greater. We'll create a new data frame and set it equal to the data frame, filtering out the average rating where it's greater than or equal to 9. Then we'll copy the histogram code, paste it down here, and then reference the new data frame. Let's go ahead and run this. And we can see by our result, we might need to make a few modifications. The modifications we'll make to the histogram is setting the bins to 10 and setting the range to the lower bound of 600. Taking a look at our result, we can see that the games with higher average ratings tend to run for longer, upwards of 2 hours. So let's scroll down to the answer, find the right skewed where the average games increases with the average rating, and submit this answer. And there we have it. I hope you got some value out of this day 19 video of the 21-day data challenge by Lighthouse Labs. I'll be back tomorrow with another video covering the day 20 challenge. See you then.